Okay, let's start this session. Good morning, everyone. This is Yinben from the Huawei IP Research Department. I'm so glad to have this chance to introduce the NeMo project, which is the network intent language. Today, the topic includes this 5 parts. First, why we need a language to program a network. The second part is what's the intent model and what's the intent language. The third part is a quick introduction about the NeMo language and the NeMo project. And then we will give a demo and following the open discussion. Okay, obviously today open is a trend. Programmability is one important type of the open. Today we already have lots of API to program network. It's work, but why we still need a different way to program network? So here, to answer this question, here I give some opinion, my opinion about the difference between this API and the language. First, API is based on functional. So it is easy to design and to provide. Because we implement some function, we can provide the interface for this function. But the API is always based on the fixed function, so it's hard to composable. But the language is based on some abstraction, some level abstraction. So the language provides some primitives. This user can use this primitive compose new service. And with the evolvement of the network capability, so the API will increase, more and more API will be provided, but the primitive is stable. When we build a new network capability, we don't need extended keyword to the language. And the API always strong related to the implementation. So the API always vendor specific. It's hard to standard. But language keyword is based on abstraction. It's a high level abstraction. It's a vendor neutral. So language is easy to standard. So the NeMo project, the target is to provide a network programming language. We just mentioned the language is depend on network abstraction. So how to abstract network? There are 2 different ways to consider how to abstract the network. The first one is bottom up. What we can open what we already have, what I can do. So today, the network open interface, for example, the tunnel, TE, VPN, lots of the technical term, lots of the network technical solution interface. But it's hard to use by the end user or the IT guy. They don't know the difference between this network technology. So if we think from the customer, there are different abstraction way. It's a top-down. We use a user perspective to abstract network. When we abstract network from the user requirement, network becomes simple because we can summarize the custom requirement to the network in 2 groups. One is the resource requirement. The second is the network behavior requirement. The resource requirement, for example, we need some connection, some bandwidth connect office site. It's a resource requirement. We need a bandwidth on demand to access internet is a resource requirement. The customer doesn't care what technical implemented the bandwidth on demand or how to connect the office site. That's a implementation detail. That's a technical solution. From the customer view, they don't care this. For the behavior requirement, customer want to control the service flow, the flowing path goes. If the security access the internet, they need to go through the firewall. How to encapsulate the packet, how to forwarding the packet, customer doesn't care. So we have a new way to abstract the network is a top-down. Today in industry, called this abstraction network is an intent. It's an intent model and the intent interface. So NeMo try to use top-down abstraction to design an intent programming language to the network. So the next question is how to express network intent clearly and effectively. So we need a structure and a grammar to the intent language. Okay, let's learn. Let's start from the real-world intent. I have an intent. I want to watch Harry Potter. This is my intent in the real world. I want is my intent. Watch is my action. I want the operation. The Harry Potter is the object. So we can summarize the intent in a common structure. Intent include operation on some object. We find some example in the network area that they have a similar structure. I want to create a virtual network. I want to block some HTTP flow, or some user want to adjust the bandwidth. That's all have a same structure. Operation on some object. In network object, the node, the connection, and the flow is a network object. We find all custom the requirement to the network. If they doesn't care how to implement it and what's the solution, they only care the node, the flow, and the connection. So we can, based on this this thinking, we can get a internet data model. On the top level, the internet model is operation and object. Operation on some object. In network area, object includes 3: node, connection, and flow. Node and connection can construct a virtual network to the customer. It provides resource to the customer. Flow is a service carried out by the network. For the operation, we can give two groups the operation. One is simple operation. Simple operation is a simple provisioning operation: create, delete, update. Advanced operation is for some operation with the condition and the constraint. For example, the query, policy, and the notification. Policy is a major control behavior to the network. It includes a condition. Under some condition, execute some action with some constraint. So we can give a very, very clear and very simple intent model to describe all the customer intent to the network. Based on this, the intent model, we want to give a real programming language. So we design NeMo language, a network domain-specific language. NeMo language was inspired by SQL. SQL is a very successful domain-specific language to the database. SQL also used the relation model, the keyword to construct their language. So NeMo, we also use the NeMo model, the keyword, to construct the NeMo language. NeMo language is very is similar to the human language. NeMo language includes three group primitives. First group is for the resource access. For example, I have 3 office sites. We use node to define the office site, node and the type and their properties. We need some connection, connect this office site, use connection, connect endpoint, and with some property or the SLA requirement. Flow, if customer want to control some flow behavior, they use flow sentence to define the flow. Flow ID and match the value and give the property for this flow. For example, queues, SLA, for example, this. The second group, the primitive, is policy and event handling, just like the operation, the query policy and the notification. Policy can apply to any entity, any object node connection flow. So policy apply to some object with a condition. When the condition, under this condition can execute some action. And the policy, we can use a transaction. So it can commit and withdraw the transaction. The third group is for the model extension, the model definition primitives. In the network, maybe in the future, we'll some new type of node or some new type of connection or new action in the policy. So the user can define this new element use this group primitives. So NeMo only have 3 group primitives and 15 simple sentences to express user's intent. But we can use the NeMo sentence create an unlimited network service. You can request the resource, you can deploy the service, you can compose the policy. Here we use an example to show the advantage of the NeMo. Here is a typical scenario for the multi-office enterprise. This enterprise have 3 offices in the worldwide, 1 headquarters and 2 branch. First, the requirement, they need to connect these 3 offices. The second, they need to connect, from the headquarters, they need to access the internet. But this access bandwidth, they hope very flexible. In the daytime, they need 1 gigabyte the bandwidth. In the nighttime, they only need 100 megabyte bandwidth. And for the third requirement is to access internet security. All the traffic to the internet, email and web traffic to the internet, all need to go through firewall before enter the internet. All this requirement is a very typical enterprise requirement. But today, the enterprise need to communicate with the service provider many times, and the service provider need to use hundreds and even the thousands command line, manually deploy this requirement to the device. All these things always need several days, even several weeks. But today, we have a NeMo language. User can self-service. They can deploy their requirement, use NeMo. Node, office site is their node. They can use connection, they can write a script, connect the branch 1 and the headquarters with the property 10 giga bandwidth, and use all the connection, describe their connection requirement. And for the bandwidth on demand requirement, they define a policy. Policy apply to the connection to. When condition, if time, when the night time, they set the bandwidth, connection to the bandwidth to 100 meg. It's very simple and very intuitive. For the security access internet, they also use the policy. first they need to define the internet traffic, define a flow one for the internet traffic, and the policy apply to this flow. Action is go through the firewall. It's very simple. But the customer use this the sentence describe their requirement, so they can directly input this script to the service provider controller. Service provider controller can understand this script and translate it to the real network device configuration and automatic deploy this service. So hold this, if use the Nemo script, only need several minutes to deploy it. So we already designed the intent programming language, but the key to implement it is it's need an engine. This engine can understand what the customer described the intent and can map this intent script to the real network device and deploy it. So in the ODR, we design an intent engine to implement it. First, we have a Nemo UI to show the running information for the service provider. And in the engine part, we have 4 major components. First is the tenant management. Tenant input their intent, need authentication and manage the transaction and construct a VN space. In the Nemo system, we provide each tenant its own virtual network. It's the tenant's VN space. Tenant can completely control their virtual network. They don't care others' network, so don't need to worry about impact other tenant or impact by the other. They also don't need to know the physical network. They only describe their virtual network. So this is the tenant management part. The second part is the physical network, because tenant describe their virtual network, but this virtual network finally they need deployed in the physical network. So we need to collect the information from the physical network, the topology, the capacity, the utilization, all the information and the status, all the information managed by the physical network manager. We already have the physical network information and the tenant, the virtual network information. How to mapping from the virtual network to the physical network. This is the intent engine. In the intent engine have several components. First, map the object. The node include the function node and the logical node, the business node. So how to map the node to the physical device? There's an object mapping component. And we need processing the operation with the condition, check the condition monitor, and execute the action with some constraint. And finally, we also need to monitor the mapping result. When the physical network, some error, some link down, or something change, we need notify the intent engine to change the mapping to deploy the new service, or sometimes even notify the customer. In the intent engine, we only this part major is some algorithm to calculate the resource allocation and flow forwarding, but the result is also abstract data. So we needed the fourth component to translate this device, the mapping result to the real interface. For example, use OpenFlow to deploy the forwarding table. Use command line, deploy the forwarding table. And this is in the render component. So this is the intent engine, the Nemo engine, the system architecture. Okay, next I will give a demo to show the Nemo. We already implemented the Nemo engine in the based on the high version, the ODL. Here is a sample. We build a physical network based on the mininet, and we have several tenants. They can use Nemo script, create the virtual network on this physical network. Okay, this is a physical network, the topology. We have 16 virtual machine connect in this network. Let's show. We already created the physical topology. We can see the physical topology, but oh, sorry. Here's the physical topology, but at this time there is no tenant. This in the OpenDI, this GUI, this GUI is for the service provider. It's monitor the tenant the requirement, but we also have another interface for the tenant. Tenant use this client to input their requirement, the Nemo script. Sorry. This tenant one, they have 3 virtual machine. They want to create 2 group, connect them. Now, first let's use the mininet. Before we create this virtual network, let's use the pin. At this time, the virtual network doesn't create, so the virtual machine cannot access. And then that way. Sorry, can we use only one? Okay, we use only one screen. Sorry. We copy the script. This script, the first part is define the endpoint, the host, the 5 host node type is a host. The second part is define the 2 group. N1 is a layer 2 group, contain host 1, host 2, 3, host 5. N2 is a layer 2 group, contain H8, H10, and a connection connect is a P2P connection, connect N1 and N2. This is a very simple script. we first we connect to the controller, use the tenant A password. Okay. And oops. Okay, we inputted the script. Okay, the script, the finish. Okay, at this time, from the service provider, the monitor the UI, we can see the first tenant A. They have this topology, and we use the in the mininet pin 1.3. It's okay. It can reach, and we pin another H8 pin. It's also okay. We can let me check from the H1 pin the H8. It's a layer 3. Okay. It's work. So use the user describe the Nemo script to create to describe their virtual network requirement. The Nemo engine can deploy this in the real network. We can create another tenant 2. The tenant 2 have a 3 group requirement, but the tenant 2 have a similar IP address with the tenant 1 in one physical network. Let's see it. Okay. We use another client because the different tenant use different client. Tenant B. Okay. At this time, we reloaded the. Okay. Here are tenant A and the tenant B. Tenant B have a 3 group, but I miss one connection sentence. So here miss a connection between these 2 group. So at this time, we can check the. Let me see the H2. It can reach H9. It can reach H15 in. Okay, but we use the H9 pin H2 or H2 pin H13. It can work. But let me check the H9 pin H13. This is work. From the H9 to H2, it's work. H9 pin 3.3.4. It cannot access because we missed this link. So let's add this from this user's script. Okay, it's success. Let me check the. Oh, We need to refresh. Okay, the tenant B have this connection three, and we check it. We just H9 pin. It's okay now. So that's so we can see we can use the Nemo script this connection requirement and the forwarding requirement, and the customer can easily describe the resource and the network behavior, the requirement, and deploy it to the controller. Controller can automatically deploy it to the real network. Okay, this is our demo. And oh, sorry. Currently, the Nemo project have a mailing list and the main page. We are encourage everyone to can participate this this project. Thank you. Any questions? Okay.
Have you handled the conflicts between the?
Yeah.
If there are any conflicts, how the engine handle this conflict?
Yeah. In the intent conflict, we need go in detail. The conflict first is there an overlap object, because our model is object operation. So first thing is there an overlap on the object? Two command, two sentence is there an overlap of the object? When it has an overlap, we need to check is there a conflict with the action. So but currently we only can check this conflict, but most of the resolved conflict we are not finished. It's the conflict resolve is important part of the intent engine. We are encouraged if industry can. Yeah, because the conflict is very complex. Because even sometimes we don't really know is it a real requirement from the customer or only a conflict. Because sometimes two sentences. One is allow the HTTP go through to the internet. Another is a deny. But we actually sometimes we don't know is it a real customer requirement or only a conflict. So it's depend on some context and more complex semantic check. Okay. Okay.
So the demo, like you have this one demo, I understand you already have an implementation.
Yeah.
Could people give you source code somewhere?
Yes. The high version, the source code we already update in the wiki side, but we are design the next version the source code and already update to the GitHub in the ODL.
Is it not in the ODL repository?
Yes, yes. Okay. Okay, thank you. If you have any question, you can send email to our team to me. It's all. Thank you very much. Okay. Oh.
Which means are you using OpenFlow or communicate to devices?
Currently, actually, in this demo, we use the OpenFlow. We use the OpenFlow agent in the ODL. We Okay, yeah. Okay, thank you. Thank you. The language is depend on network abstraction. So how to abstract network? There are two different ways to consider how to abstract the network. The first one is bottom up. What we can open what we already have, what I can do. So today the network open interface, for example, the tunnel, TE, VPN, lots of the technical term, lots of the network technical solution interface. But it's hard to use by the end user or the IT guy. They don't know. But the API is always based on the fixed function, so it's hard to composable. But the language is based on some abstraction, some level abstraction. So the language provides some primitives. This user can use this primitive compose new service. And with the evolvement of the network capability, so the API will increase, more and more API will be provided, but the primitive is stable. Okay, let's start this session. Good morning, everyone. This is Yinben from the Huawei IP Research Department. I'm so glad to have this chance to introduce the NEMO project, which is the network intent language. Today, the topic includes this 5 parts. First, why we need a language to program a network. The second part is what's the intent model and what's the intent language. The third part is a quick introduction about the NEMO language and the NEMO project. And then we will give a demo and following the open discussion. Okay, obviously today open is a trend. Programmability is one important type of the open. Today we already have lots of API to program network. It's work, but why we still need a different way to program network? So here, to answer this question, here I give some opinion, my opinion about the difference between this API and the language. First, API is based on functional. So it is easy to design and to provide. Because we implement some function, we can provide the interface for this function. When we build a new network capability, we don't need extended keyword to the language. And the API always strong related to the implementation. So the API always vendor specific. It's hard to standard. But language keyword is based on abstraction. It's a high-level abstraction. It's a vendor neutral. So language is easy to standard. So the NEMO project, the target is to provide a network programming language. We just mentioned